Hello, this is Mr. Stansbury. I'm going to take you through the 19F notes on tangents to curves. At the end of this, you should be able to say I can find the equation of the tangent to a curve at a given point, and I can find the horizontal tangents and tangent points to curves. Okay, so let's start off with an example. This is example 8 from page 617. We're going to find the equation of the tangent to the function x squared plus 1 at the point x equals 1. Okay, so let's break down what we're actually looking at here. Okay, so what they're really asking us to do, here's the equation f of x equals x squared plus 1. So that's this red line here. And what we want to do at the point x equals 1, we want to find this tangent line right here. They're asking us what is the equation of this tangent line. Okay, so in order to find the equation of a line, we need the slope and we need a point. Okay, that's on that line. So here's what we want to do. Okay, first we want to find the coordinate for the x value. We're going to plug 1 in for x so that we can find y. All right, so here we go. So again, on this we already know that the x value is 1. What we want to do is we want to find the y value. Okay, so to do that, we're going to just plug 1 into our equation. Okay, so f of 1 is simply 1 squared. That's terrible. 1 squared plus 1. So that gives us 2. Okay, so we've done step 1. We've found the point. Okay, so this is the point that we're going to use to find the equation of our line. And then now the second thing we're going to do is find the slope of the tangent line. Okay, so finding the slope of the tangent line is just finding the derivative. Okay, and then once we find the derivative, we plug that 1 in, this right here. We plug that 1 in for x. Okay, so first things first, let's find the derivative. So f of x is x squared plus 1. So f prime of x is our derivative. So to move the 2 out front here, 2x, and then we subtract 1 from the power there. So that's 2x to the first. And remember, this is x to the 0. And 0 times anything is going to be 0. So at this point, hopefully you're starting to realize anytime you take the derivative of a constant, so this plus 1, anytime you take the derivative of any constant, it's always going to be 0. So that derivative just goes away. That when you take the derivative, that is irrelevant. Okay, so here's our derivative function. So now what we want to do is we want to plug this 1 here in for the x. So now we would say, well, let's find f prime of 1. And that would be 2 times 1. So f prime at 1 is 2. So what this is saying is that the slope of the tangent to this function here at point 1 is 2. So this slope here is 2. Okay, so now that we have the slope is 2, all we got to do is find the equation of the line, and that is step 3. Plug our point and our slope, and there's our slope. Plug our point and our slope into the point slope formula. So we got y minus y1, here's y1, and here's x1, and then here's our slope here. So y minus 2 equals, our slope here is 2 times x minus 1, and then now we're just going to solve for y. So y minus 2 equals 2x minus 2, distribute the 2 through, add 2 to both sides, and we get y equals 2x. That is the equation of this line right here. So look, there it is. Just happened to draw that right through 0. And then the slope of this line is 2, right? Because if you look at this here, here's 0, 0. And here's the point 1, 2, which we know is on the graph because there it is right there. At the slope between those two is 2. So your equation y equals 2x. All right? Okay, let's try another one of those. Okay, so this is example 8b. Find the equation to the tangent to f of x equals x squared plus 1 at x equals negative 3. So same exact equation. Now we're just going to find the slope, the equation of the tangent line at a different point. Okay, so let's just go through the same steps again. So if you'll remember, the first step is to plug this negative 3 into the function and get our point. Okay, so f of negative 3 is It's x squared plus 1, so it's negative 3 squared plus 1. So f of negative 3 squared is 9. So f of negative 3 gives us 10 because we got 9 plus 1. Okay, so we now know that our point is negative 3 and 10. Okay, next thing we want to do, remember, is we want to find the slope. So that's where we have to take the derivative. F prime of x is, let's see, we take the 2 out front here, right? So we get 2 times x. We already did this once. So 2 minus 1 is 1. And then remember, the derivative of any constant is 0. So there's our derivative function. And then now to find the slope at negative 3 is we take this negative 3 and we plug it in for that x there. So f prime of negative 3 is 2 times negative 3. F prime of negative 3 is negative 6. And again, remember, this here is the slope of the tangent line. Okay, so now that we have the slope and a point, now we just plug that into the point slope formula. Y minus y1 equals m times x minus x1. All right, so y minus 10 equals the slope, which is negative 6, times x minus negative 3. So in this case, that's x plus 3. Y minus 10 equals negative 6x minus 18. Add 10 to both sides. And we get y equals negative 6x minus 8. And that is the equation. That's the equation of the tangent to the function at x equals negative 3. All right? All right. All right, let's take a short little video break, shall we? Found some videos about animals. I think they're pretty funny. Sorry, that's you got to admit that's pretty entertaining. All right, we're at 7:40. We're running a little low on time here, so we'll just start this up on the next second half of the notes, and we just have 2 more examples, and we'll be done. All right, see you in a bit.